GAC, what it do? It's Coach Jay in the house. Hope you're having a good night tonight. We are underway. I know I'm starting like maybe a minute or two early, and actually I need to charge my Mac. But again, I'm here for you. Questions? Any questions you need, let me know. If you do give me a question on that, make sure that, like, let's say you say number 5, make sure you say 5A or 5B, A being the first one, B being the second one, because there are two problems per question that's there. Remember, you only have to do, I think I said 30 out of the total that are there. You feel free to do what you need to do on the review. Focus on the ones you don't know. We'll rock and roll from there, okay? All righty. So, without further ado, let's get it started right now. We are today going to focus on, I'm going to get this underway. We're going to focus on the main part of this, trying to figure out what type of formula we're using. And I kind of said that again and again in class, but it's so true. The more that I can actually identify with formula that I'm using, the better that I'll be. And again, feel free to text me on Remind 101 or on my cell, or even email. I'm starting to get emails through here. I could kind of identify them there. And again, if you see any questions on there, please let me know, and then we'll go forward on that, okay? All right. The one question that I had recently is, I know Cannon said he wanted to do one. All right, let's see here. The question that he had was one concerning, I think it was number, I just want to make sure I'm identifying this right. Yes, okay, so number 1, let's take a look at that. We'll do 1A. And then we will go forward. Okay, so we're going to do 1A here. All right, so remember that anytime that I'm identifying this, there's a couple keywords, and even if you carry a highlighter or something with you, start circling words or putting things in parentheses or something to help you out. So for instance, when you see it, it says find the sum. So maybe you circle sum to identify, okay, we're finding the sum of something. We know it's also the first 12 terms. So we know that we're talking in terms of a finite sequence. If it was infinity, it would keep going on and on and on. That's what the ... is for. We also know it's geometric. So if we know that it's geometric, we're trying to find the sum of 12 terms. We know what formula we're going to utilize, right? All right, so we're going to use the formula S of n equals A1 times 1 minus r to the n power all over 1 minus r, okay? So we're going to utilize this formula right here. Now, we know that A1 is 5, so we're going to plug 5 in for A1 there. We also know that the R is 0.6, so we're going to plug that in, 0.6 in for R. And when we simplify, we also know that the 12 is for n, right? In this example, n stands for the amount of terms that we're summing up. So, so we could actually say S of 12, meaning the sum of the first 12 terms. So once I plug that in, 0.6 will end up being to the 12th power. Now, I will pull this up for my calculator just so that I've done it once here. I don't want to be careful and sensitive to your time in terms of going too in-depth in this, but we're going to take this one step by step. Let's see if we can get this underway as it comes up. Let's see here. Hello there, friends. Let's go. Coming up here. Coming up. All right, while that is coming up, if you do have any other questions, throw them out there. Give me the number. We'll go through that together. I thought I saw another one I wanted to do. We'll get to that in a second, I guess. Okay. Let's do this one. All right, so when we do this, the first thing we want to kind of do is go to 0.6, and we're going to take it to the 12th power, okay? Now, if it was negative 0.6, make sure you put it in parentheses. So what I might want to do is just so that you know, let's put 0.6 to the 12th in parentheses, and then we'll delete all this other stuff. Okay, and we'll put that there. Now, this right here would be the top right side. Okay, so we're going to press enter, and then we're going to say 1 minus, and we're going to take this answer, we can actually go second, this negative, which is 1 minus the answer above. When we press enter, we get 0.997, okay? Then we're going to divide this by parentheses, and we'll put the whole thing because we can, it's a little easier here. 1 minus 0.6. We'll close it. So what happens is it'll do it this first, then divide it. And when that happens, we get 2.49. Then we'll multiply by 5, which is our first term. And when I do that, I get 12.47. Okay, so 12.47 as my sum there for the first 12 terms. So once I do this, just like I showed you there, 12.47 would be my answer. Okay, awesome. Awesome. I've got number 20. I've got a very loyal guest on here. A little shout out there on that side. Okay. Yeah, we'll do a Pascal triangle one too. I just got that one as well. All right. So I've got one, number 20, and then I'll do a Pascal's triangle. Okay, so what's cool on number 20, and by the way, just a heads up, you will be able to throw out any one on the test, and you will be able to mark one a bonus. The reason why I'm doing that is I understand that with this week trying to get back into it's tough, but that means we should be good. If you know this review, and then man, that means you got 2 freebies on that side, so that's money. All right, so first thing it says the sum of a finite arithmetic sequence. So if we know sum of any arithmetic, we know we go straight to this formula. Okay, that's what's nice, right? Where n stands for the amount of terms I'm summing up, right? So that's what all of these n, so that's what you plug it in for. Now what it says is this follows. It says the sum of the arithmetic series is 240, which is a little different because we've never been given that quite like that. So we'll come back to that. It says the first term is 10. So what we'll do is we'll drop down and we'll put 10 in for A1. And then they said there's 12 terms. So we're trying to find, if there's 12 terms, we'll put 12 in for n. Okay, a sub 12. Okay, that just means the 12th term goes in there. Equals s sub 12, which means the sum of the first 12 terms. Okay, so what does 240 go in for? Well, what it does is it gives us that the sum is 240. So that means that 240 legitimately will be plugged in for s sub 12 because that is the sum. So 240 equals, we can reduce this, 6 times 10 plus a 12. Now let's look and see what it says. It says find the value of the last term. So what we want to do is we want to find the value of this term here. So this is our variable. So what we'll do is, just to simplify, we'll distribute 6 across to get 240 is equal to 60 plus 6, and we'll just keep it as a for shorthand. All right, so we're trying to solve for that. So we're going to subtract by 60 to get 180 is equal to 6a. Divide by 6, divide by 6. 30 is equal to a sub 12, which means that that's the last term, okay? So the last term, which is the 12th term, is a value of 30. And that's how I would find number 20, okay? I actually like that one because it's not too bad. It's just setting it up in the formula and going from there. Again, the key is to know what formula to use and then to plug in the specific values in for what we know, okay? Once you do that, you should be golden. All right, let's do number 19. That's a really good one. Number 16 is another good one if you wanted to check that one out in terms of Pascal's triangle. But we will go to number 19, 3 minus 2i. So let's talk about this first. When we do any Pascal's triangle, you can have the Pascal's triangle there. So you'll have 1, 1, 1, 1, 2, 1. This is what you would have there, okay? You could actually write this on your formula sheet. Now remember that when we have Pascal's triangle, the key is that we will have one greater term than power. So anytime you forget, let's say I have a 3 here, that means I should have a value of 4 terms. We should have 4 total terms. If I had one like up here, where I have it to the 4th power, that means I would have 5 terms. So coming back to 19, with the 3rd power having 4 terms, I am looking at 1, 3, 3, 1 because of the fact that there's 4 terms here. So I'm going to write that 1, 3, 3, and 1. Now, how I plug this in is as follows. We know that 3 and negative 2i is my first and then second value. But before we do that, let's put in x to the highest power, which would be 3, then x squared, then x. Now, going backwards the other way, we'll start with y. So we have y to the 3rd, y squared, and y. Now, what the heck does x and y stand for? Right now, in your house, I want you, just like Dora the Explorer, to yell it out. What do we plug in for x? I can't hear you. Very good, better. What do you plug in for y? Yes, people think you're strange. It's okay. People say that about me too. Very nicely done. We have x is for 3 and negative 2i is for y. So it should look like this. 1 times 3 to the 3rd, 3 times 3 to the 2nd. What goes in for y? Negative 2i. Third one, 3 times 3 and negative 2i squared. And then my last one is 1 times negative 2i to the 3rd. So let's take it step by step, and then we'll finish it off. So 3 to the 3rd is 27, times 1 is 27, so we keep that there. Check 1. Check 2 is 3 squared, which is 9. 9 times 3 is 27. 27 times negative 2 is negative 54. Remember, we distribute each of the ones in yellow, right? So I kind of divided these out between 4 different sections, right? Okay, so this is negative 54, and then we just include that I that's there. Okay, so that's number 2. Number 3, a little bit different. We're going to take the 2 and we're going to apply it to both of these. Okay, so negative 2 squared is 4. 4 times 3 is 12. 12 times 3 is 36. So we're going to have 36, but then don't forget this I. This also will be squared as well. So we have 36 I squared, which, again, anytime I see I squared, what do I do with it? That's right, I change the sign or make this negative 1. So negative 1 times 36 is negative 36. Now my last value is negative 2. So we have negative 2 to the 3rd, which would be negative 8. And I to the 3rd would be here. So if I have 3 i's, that means one pair produces a negative 1, right? Because I squared is negative 1, and an I. So it should be negative 8 times negative 1, which is 8, and then I include an I at the end. So that should be positive 8I. And I'll put this out so you don't get confused, but that's that simplified right there. Okay? Again, if you have questions, keep texting me. I can always come back to this later on. Now we add and subtract like terms. 27 minus 36 is negative 9. Negative 54i plus 8i is negative 46i. And so negative 9 minus 46i should be my answer there. Okay? I hope that's helping out with what you were asking for me. Hopefully that's helping out going forward on that, okay? Awesome. All right, I'm getting a lot of these questions answered. You want to throw another one out at me? Come on. As I look down the list, let me see if there's any other ones that I feel like we might struggle with. Okay, let's see. Ooh, let me give you another 23. So if you look at number 23, I'm going to, I'm gonna do it on a blank one. Is that cool? So I'm gonna put this one here. So this one is just for an extra one, okay? So we're gonna say x minus 2y to the 6th, and I want you to find the 3rd term, okay? Now, anytime I identify the 3rd term, or if you look at one like number, trying to see another one. Again, 23 is a good example, but there's another one that I did, I think in one of the classes at least today. Number, no, I can't find it. Number 9's a good one too. Very similar, kind of 9's a little bit tougher, but same concept, okay? So this is NCR, okay? X to the N minus R and Y to the R, okay? So let's talk about a couple things. First off, this is all on your formula sheet, right? All of this is, including what I'm about ready to put here. But N is the power of the expansion. In this case, we'd have the power of 6. And R is the term that I'm asking for, subtracted by 1, okay? All right, so what we want to do is we want to identify what's N and what's R. So first of all, the power of the expansion would be a total of 6. So what we do is let's plug 6 in for N. So we're going to have 6C. And when I look for R, let's look for R here. The term subtracted by 1. Well, if I ask for the third, we're going to take 3 and subtract by 1 to get 2. Okay? So where N is 6 and R is 2. So I'm just plugging values in, getting it out. So once I simplify this, I should get 6C to X to the 4th, Y to the 2nd. But remember, X and Y do not mean anything. All that means is this, that for the value of X, we're going to plug in the first one, which is, in this case, it's X. So actually, if I plug X in for X, what I see is what I get, okay? But for Y is a little different. This time, we got to plug in negative 2Y in for this Y here, because that's the second term. So what we would do is we would say negative 2Y would be to the second power. That's why I bring that down over here, okay? So I could rewrite this as 6C2 X to the 4th, negative 2Y to the 2nd, where all of this would then be distributed. Now, on your calculator, let's look at this real quick, just so that you've got this, a rep in on this one. Make sure you bring in your calculator. That's very important tomorrow, okay? Just a heads up there. Let's see here. All right, perfect. So let's say that we did 6C2. Some of you are a little different. Actually, I'll do it this way because it works either way on my calculator. You want to first put 6 down. Then you're going to go to the math button, to the probability, P-R-O-B. You go to NCR, and then you're going to put 2 in, just like so. Once I press enter, I get the value, which in this case would be the value of 15. For some of you, you'd have to just put it right at the end. It looks a little different, but kind of the same style there. So let's pull this bad boy up. Okay. Sorry, coming up here. So we know that 15 would be the 6C2 here. So what we can do is we can then plug this in to say 15 X to the 4th, and when we do negative 2 squared, we get a value of 4, and then we'll get Y to the 2nd, which would be Y squared, right? So 4 times 15 is 60 there. 60 X to the 4th, Y to the 2nd. That right there would be my answer. We would leave that as is. That would be our third and final term, okay? The only other thing that I will say is that on number, the one that I think we did even in class today, the one that's on number 9, look at that one real quick. That one's a good one too in terms of kind of just figuring out what to do with that. Remember, it's still NCR, X to the N minus R, Y to the R, right? The only problem with one of these, I think it's the second one, is it should be 3X plus 2Y to the 6th power, right? Where again, same thing, 6 would be X, right? Like or N, I'm sorry. 6 would be N here. And R, you would have to kind of figure that out in terms of the fact that they gave us that it's X squared Y to the 4th. That means the Y to the 4th, that means R would have to be 4, right? So you could kind of plug it in and kind of solve it accordingly. Again, 3X would go in for the X value because it's the first term, and for Y, we'd put in 2Y. For the second term there, okay? Awesome. Do you have any other questions there? Oh, number 9. Oh, let me take some of my time then. I'm sorry. Just solved number 9. Let me take my time through this one. Okay, let's do that. That is Gucci. Okay, so now that we know, again, you'll have this on your formula sheet, Lord willing, okay? So we know that 6 is n. We just talked about how the fact that whatever the power of the expansion is, that's what goes in for n. So we have 6 is in for n, okay? And to get r, we know that it's x squared y to the 4th. So that means because of the fact that it corresponds here, whatever the y powers to, that's how we're going to find r. So we're just going to have y to the 4th, put 4 in for r. So we could rewrite this as 6c4 x to the 2nd y to the 4th. Again, what we're trying to do in this example, if you read it, is we're trying to find the coefficient that goes in front. So what value, what whole number would go in front of x squared y to the 4th? So when addressing this, we know that for x, we're going to plug 3x in for that. So we have 3x squared. And for y, we're going to put 2y. So 2y to the 4th. So we have 6c4, then 3x to the 2nd, and 2y to the 4th. So you could do this on your calculator if you want to. As I think through that, I believe we get 15 again. I want to make sure. Yeah, I believe we get 15. So this would be 15 here, either on your calculator or by hand. Either one of those is fine. And again, heads up, you'll have your calculator for the whole test, okay? Whole test, if you want to, okay? Then we'll have 3 to the 2nd and x to the 2nd. So 3 squared would be a value of 9. X to the 2nd would be x squared. So that would be this part. The next part would be 2 to the 4th. Well, if you put 2 to the 4th in, that would be 16. And remember, don't forget to also include that with the y. So we have y to the 4th. So once we have 9 times 15 times 16, we're going to distribute that out. 9 times 15 times 16 to get 2,160 as the coefficient that will fall in front of x squared y to the 4th. So that's how I would put the coefficient that's in front there. Okay, look at number 9 too. Remember, in this case, n would be 7, whereas r would be 5, right? So that's just a heads up there. If you have a question on that, we could do another rep on that either today or into tomorrow as well. Okay. All right. Currently, I do not have any other questions right now. That doesn't mean I'm done. But if you have any other questions, the door is open. All right, let's see here. Trying to just kind of work my way backwards here. Number 22 is a good one too, because that one's one where it says each row in a small auditorium has 4 more seats in the preceding row. Well, if it has 4 more seats, that means I'm adding 4 at each row, right? Well, automatically I should think, okay, arithmetic, right? On number 22. So once that happens, it says find the seating capacity of the auditorium. If the front row seats 12 people, okay, so here's A1, right? And it says, and there are 25 rows. So we're trying to find 25. So really, we're trying to find the sum of 25 rows, really, right? And we remember that arithmetic would be n over 2 times A1 plus A sub 25. And I guess I could plug 25 in here because I know that there's 25 total rows. So what we can then identify is what's the first term, what's the first row? Well, we know it's 12, so we could plug that in. So we have 12 here. 25 divided by 2 is 12.5, so we can hold on to that. So S sub 25, which is the sum of the first 25 rows, equals 12.5 times 12 plus A sub 25. Now, remember, A sub 25 is the 25th term. Now, here's where it gets a little tricky. Because of the fact that we can't have 2 variables, and the fact that we're trying to solve for the sum, we're going to find A sub 25 by plugging it into our formula. So we'll have A sub 25 equals A1, which in this case is 12, plus D times n minus 1, which again is 25 minus 1. Now we remember that D, because we add by 4 each time, right? We add by 4, we add by 4, we add by 4. Once we identify that, we'll put 4 in for here. to get a sub 25, or the last term, is equal to 12 plus 4 times 24. So once I do 24 times 4, I get 96. I'll add 12 together to get 108 within the last row, okay? So then we'll have 12 plus 108 on the inside of the parentheses multiplied by 12.5, okay? So we'll add this on the inside. We end up getting 120. 120 times 12.5. Well, that will end up getting me, I believe, 1,500, I believe. Let me try to do that in my calculator. Try to do that in my head. So, and I hear 16B right there. I hear 16B. I'm going to come on that one there in a second. Just checking on myself. 12.5 times 120, and we get 1,500. It's correct capacity. Right there's our answer. Okay. Now it's a little bit tougher again, identifying what formula am I using, what am I missing, and then kind of executing it accordingly. Okay. Awesome. 16B. Man, that's a good one. Man, y'all keep giving me all the good ones. 16B would be this one here. Okay, 16B. Coming back to this one. Perfect. Okay, just like Pascal's triangle, we're trying to look for the row that has one greater than, probably white on white won't work there. Let's try that. One greater than the highest power. So we're trying to look for something that has 6 different terms. So if you remember that, I believe the 6 different terms would be, we can kind of do it. So 1, 1, 1, 2, 1. And again, you don't have to memorize this. You can kind of, again, just put it on your formula sheet there. I think that's it. So 1, 5, 10, 10, 5, 1. So we're going to really spread this out. So 1, 5, 10, 10, 5, 1. And this is the best way that I know how to kind of explain it. So now what we're going to do is we're going to take x, which just means it's the first term. We're going to take it to the highest power. So x to the 5th, 4th, 3rd, 2nd, 1st. When x decreases left to right, y decreases from right to left. So y to the 5th, y to the 4th, y to the 3rd. Each of these exponents, for the most part, unless there's an exponent within this expression, but for the most part, these should add together equal the highest power, in this case 5. So now what do we plug in for x? Well, in this case, since x is, x is x, so that's kind of nice. So we could just leave any of these x's. I can leave because the first term is x. So the next question is what about negative 2y? Well, since negative 2y is the second term, we're going to plug that in for wherever we see y. So we have, in this case, negative 2y. Over here, this is negative 2y to the 2nd. Here. This is negative 2y to the 3rd. Negative 2y to the 4th. And negative 2y to the 5th. Okay? Now, as we go through, we simplify almost as if they're all little problems, right? They're all separate in some regard. So this will be x to the 5th. This one is 5 times negative 2, which is negative 10. X to the 4th. And then I have a y. Okay, so that's the second one. The third one is 10 times negative 2, which is negative 20. X to the 3rd. Oh, I'm sorry. My fault. Hold up. My fault. I want to be careful because this will mess me up. I've got to do the power first, right? Negative 2 squared should be 4. 4 times 10 is positive 40. That makes a big difference. Just be careful on that. You want to check these. X to the 3rd, y to the 2nd, because that 2's got to distribute. The next one is negative 2 to the 3rd, which is negative 8. Negative 8 times 10 is negative 80. X to the 2nd, and remember the 3 also goes with the y, so we have y to the 3rd. The fifth one is negative 2 to the 4th, which is 2 times 2 times 2 times 2. In that case, it's 16. 16 times 5 would end up getting me 90. And we'd have x, y, remember because the 4 goes to both, x, y to the 4th. And then my final one is negative 2 to the 5th. And once I can even plug that in my calculator, we know it goes to both. Negative 2 to the 5th is negative 32. And we'll keep it as y to the 5th power because that 5th power would also be to the y as well. Okay? And that would be my answer. I know that that's a little tougher in terms of solving that one there, but that would be it. All right. Good question. Man, that was a really good one. Does anyone else have any other questions out there? Keep them going. We've done those. Let's do number 18 because that one is one that is a little tricky. We'll do the bottom one. It says find a formula for the nth term of the sequence. Again, you'll have all the formulas to be able to aid you in simplifying this. One of the things that you kind of have to identify, at least for tomorrow, is what's happening. Well, as you go from one to the next, right, you'll start recognizing in a hurry that in this example, we're adding 2 each time, right? So what we can do is if we're adding 2 on the top, right, because when we have a rule for the nth term, we're trying to find a sub n equals, but we're trying to find what the top rule and bottom rule is. So for instance, on the top, we can identify that we're adding 2. So let's try n plus 2 to see what we get. So in this example, if I plugged 1 in, 1 plus 2 is 3. Okay, so I look at that and think, well, I don't think that that's the case. I then look at it and say, okay, what would be the second term? 2 plus, or second term would be 2 and 2 to make 4. So really, even though we're adding 2, the reality is we're not saying n plus 2. We've got to do something just a little bit different. So instead of doing that, since I know I'm adding 2 on the top, let's say 2n. I know that sounds weird, but remember, the arithmetic sequence is a1 plus d times n minus 1. The d times n minus 1 is what is kind of brought to the table in terms of the top side. So let's try 1. 2 times 1 is 2. Plug in 2. 2 times 2 is 4. 3 is 6. 4 is 8. And we've got ourselves a winner on that top side. Now on the bottom side, you'll notice that each time we're multiplying by 4. So if I'm multiplying by 4 on the bottom, instead of thinking 4n, that's not right, let's think 4 to the n power. Now, the kicker with this is the fact that since n begins with 1, we plug 1 in, and when we do that, we get 4 to the first, which is 4. Then we plug 2 in, 4 to the second, which is 16, okay? Plug in 3, 4 to the third is 64, and you'll notice that we're 1 off because we have 4, 16, and 64. So to make it a little bit easier on ourselves, we're going to take this n, and instead of saying 4 to the n power, we're going to say 4 to the n minus 1, because that will allow us to move backwards 1 spot and have a value that's before this 4, 16, and 64. And now once I plug in 1, 4 to the 1 minus 1 power, 4 to the 0 is 1, and that actually identifies what we're looking for there. So we'll say 4 to the n minus 1, and 2n would be on the top side. That's how we find the nth term of the sequence. Okay? Good. Number 15, just a heads up on that. Make sure if it says the sum of the infinite geometric sequence, we know it's a1 over 1 minus r, where a1's the first term, be negative 8, and r is the number that I multiply by to get to here, right? Again, it tells me geometric, so that's a huge hint on what one I've used there. Well, negative 8 is not changing on the top, if you notice that. The only thing that's changing is the bottom. So what we would like to do is see, what do I multiply by to get from negative 8 to negative 8 thirds and negative 8 ninths? Well, I could actually multiply negative 8 times 1/3 to get to that next value. So what we would have now is negative 8 over 1 minus 1/3. Well, 1 minus 1/3 is 2/3 there, because we have 3 over 3. Okay, 2/3. And we'll have negative 8 over 2/3 there. We'll simplify by distributing by the reciprocal. So we have negative 8 times 3 over 2. 2 goes into 8 4 times. Negative 4 times 3 would be negative 12. And that negative 12 would be the sum of the value for the infinite geometric sequence, okay? All right, take a look at 14a. I think I did 14b in a lot of our classes today. So 14a says find a rule for the following sequence. So we're trying to find a sub n equals. Well, as I notice from one to the next, I am adding by 8 each time, okay? So if I'm adding by 8, the easy part about this is we can go straight to our formula, which is our arithmetic formula, right? Where n, we don't know what n is, but d is 8, right? So that's what we'd be adding. A1's the first term, which is 13. So we would say 13 plus n minus 1 times 8. So we'll distribute the 8 to the n minus 1 to get 8n minus 8. And once I simplify that, 13 minus 8 is 5. And we'll say 5 plus 8n equals a sub n. And that right there would be our answer for our rule for the following sequence. Now, on 14b, it's a little tougher because, again, now you're seeing 2 to some power, right? So actually the rule for this one would be 2 to the n power, where n is 1, right? And then 2, and then 3, and then 4. And then on the bottom, because of the fact that this is 3, 9, 27, 81, you could then say 3 to the power of n as well, because as I look at it, I plug 1 in to get 3, 2 to get 9, 3 to get 27, and that would be my rule for that one, okay? Awesome. Remember, if I say find the first 5 terms of the sequence, you could plug this in your calculator, being careful to keep the parentheses that are there in order. The big thing to remember is that for the nth term, we plug in 1, 2, 3, 4, and 5 in for n. Once I get that out, I will then have my first 5 terms of that sequence that's there, okay? I think I did one of these in class, but if you're confused, maybe just asking me before class is sufficient. You can use your calculator, so feel free to do so moving forward on that, okay? All right. On this one, it says find the sum of the first 30 terms. Again, we're trying to find 30 terms, so that's something that's important. One thing to recognize is what type of summation are we using? We know it's going to be either geometric finite because it's 30 terms, or it's arithmetic. But as you look at 1/2, from 1/2 to 0 to negative 1/2 to negative 1, you could say, oh, I'm trying to multiply, but really we're not. We're trying to, in this case, subtract by 1/2 each time, if you see. Because if I have 1/2 minus 1/2, that's 0, minus 1/2 is negative 1/2, minus 1/2 is negative 1, okay? So those are pretty good there. So once I know that it's arithmetic, I can say S sub 30, because that's 30's n, equals 30 over 2 times A1, which is 1/2, plus what our last term is, and that's where I have to find A sub 30. Now, that would be a little tougher, very similar to what we've done previously. We could find it by using our equation A sub 30 equals 1/2, which is our first term, plus D, which is negative 1/2, times 30 minus 1, okay? 30 minus 1 is 29, and we multiply by negative 1/2, and then I'll add 1/2 to it, okay? So we'll do this here. We should have negative 29 over 2, and then I'm going to add 1/2 to it to get negative 14 as my A sub 30, okay? Negative 14. Okay, so negative 14 goes in for A sub 30 here, okay? So negative 14 plus 0.5, which is negative 13.5, okay? So all I did was simplify. This was just to find the term that's here, and now we're trying to just work inside out. So negative 13.5 is there, multiplied by 15. My sum should be negative 202.5, and that's S sub 30, okay? All right, questions on that? Please text me. I haven't had a lot of texts recently, but I'm just kind of going through these together. So again, if you have questions, let me know. On these two, 9 and 10, I kind of hit those already in terms of how to approach those. But if we need another one, we could do it. Well, we could do it now if you give me a text there, or we could do it in class if need be. on that going from there, okay? Just make sure I don't have any emails, too many emails. Okay, perfect. All right, so as we find number 8, you'll notice that number 8 says find the 23rd term of the geometric sequence, right? So first of all, geometric means we'll say a sub n equals a1 times r to the n minus 1 power, right? So if we're finding the 23rd term, 23 is what we plug in for n, okay? So we have 23 minus 1, where r, they gave that to us, is the square root of 3, and a1 is 3. So really what we're doing is the square root of 3 to the 22nd power, okay? All right, so we'll do the square root of 3 to the 22nd power, and then I'm going to multiply that by 3, and I'll get a pretty large value. I got 531,441. I think I did that one in that class, something like that. But that's how I find a sub 23, which is the 23rd term there, okay? All right, awesome. We can go over the easy ones on the front page. That's awesome. Someone just texted me now, exclamation point, exclamation. If you did that, I'm not sure what that means, what now means. I think I did that number 9 already, though. If I didn't, hold me to that. Oh, you know what? You might have meant number 9 on the front, and if so, please let me know on that. Oh, okay, gotcha. So we're talking in terms of 9 and 10. Okay, so I think, okay, perfect. So the front page, the easy page is what you're asking for. Okay, I was wondering, I'm sorry about that. I was trying to go through, I know I have a bunch of different numbers. I'm just trying to give you a bunch of different examples on this one. All right, so on the front page, we have 10 right here, right? And we have n equals 1. This is n squared minus n all over n. Now, what's cool about this is you could actually plug this in your calculator and get this out. Remember, this symbol is called sigma notation, which means we're finding the sum of n squared minus n over n, where 1 is the starting value, 10 is the ending value, okay? All right, so let's go to this one. Let's see here. So what we'll do, just to kind of give you a refresher, we're going to plug in and actually have it in here. X squared minus x, which is, this is n squared minus n. Just be sure to put all this in parentheses on the top. And then divided by, in parentheses, n. Again, I put that in parentheses just to be sure. Once I put that in for y, I can go to second graph, and right below I should be able to see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which stands for the first term, second, third, all the way to 10. And what I could do is whatever I get out, in this case it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, I could take all of these values, and because it's sigma notation, I can actually add all of those together to get one common value. And so that's kind of what we're looking for, where we're just adding all of the ones from 0. Let me see, I want to make sure I read that right. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those were the answers. Once I plug all those out, I can just add them all together. That's how I get the summation of that specific value there. Okay. On number 4, 5, and 6, that one's very similar to what we've done earlier, where we're finding the first 4 terms. We're going to plug 1 in for n, 2 in for n, 3 in for n, 4 in for n. And once I get those values out, that's simple. We just list out what the first 4 terms of that sequence is. The one that may have been a struggle for some, I wanted to hit on this one. This one's a good one. Okay, this one where I have like 4 to the 3rd plus 5 to the 3rd plus 6 to the 3rd, right? And so on and so forth. The important thing to know, I know a lot of people think it's arithmetic, but let's say I have 4 to the 3rd here. I wanted to show this to you. 4 to the 3rd would be 64, okay? 5 to the 3rd, 5 to the 3rd is 125, okay? So I'm just simplifying this out for us. 6 to the 3rd is 216, and so on and so forth. Well, you obviously know I can't multiply to get from 64 to 125. So this is not geometric. I also look and say, well, can I add or subtract by anything to get to the next value? Well, if I took 125 and subtracted by 64, I would find that I would add 61 to get to the next value. But if I went from 125 to 216, you'll notice I would have to add 91 to get to the next value. So, Coach, you're saying, what are you trying to tell us? This is not geometric. This is also not arithmetic. Just because I have an addition symbol doesn't mean that I'm adding or subtracting by something that is the common difference. You have to make sure that these numbers match up. That's the key. So as you go through this, that's something to just kind of identify with. Whereas if you look at this next one, number 1, 12, -4, 4/3, -4/9, you'll notice that to get from 12 to -4, yes, I subtract by 16, but I can't subtract by 16 to get to the next one. So it's not arithmetic. But I look and see if I divide this by 3, right, or multiply by 1/3, and I know this is negative, so -1/3. If I multiply 12 by -1/3, and this is just kind of trial and error, 3 goes into 12 4 times, I would get -4. Then if I multiply that by -1/3, I would have -4 times -1, which is 4. 3 times 1 is 3. And I get 4/3. And you'll see that pattern over and over. So we say that this is geometric. And we say the common ratio is the fact that it's multiplied by -1/3. And that would be my ratio for that specific sequence, okay? And the last one that I wanted to look at is one where if I have 9 exclamation, 6 exclamation, again, this is what we call factorial, simplify the factorial here. 9 exclamation is 9 times 8 times 7 times 6 times 5, ... right? 6 exclamation, we can hold on to that, and I'll show you why. Down below, keep it as 6 exclamation. And 8 exclamation is 8, 7, 6, 5, 4, 3, ... right? Now, since this is the exact same thing top and bottom, we can actually cancel these out. And because of 8, 7, 6, 5, 4, 3, ... is on top and bottom, we can cancel that out, leaving me with the value of 9. So that's what the final value would be there, okay? Also, good. We've been going hard at it right now. I think for close to about 50 minutes almost. Does anyone else have any other questions at all? I'm pulling things up right now just to make sure that I'm clear. Done all of the ones that does that cover the easy ones on the front page there? Double A's, that makes sense. Hope that makes sense for y'all. Is there any other ones that you feel uncomfortable with? Again, highly recommend. I gave you 2 sets of problems. Tonight would be, I'm just telling you, if you really want to do well on this test, pull it out and ask yourself, okay, what equations do I use for each one? It might even be a decent strategy to go through each problem and at least initially write down the formulas that you would use for every single problem, okay? Also, I'm interested to see if this would help tomorrow. Give me feedback on this. You can even text me right now if you want to. But my plan is that there's 22 total problems. You only be required to do 20. Though some of these are difficult, they're tricky, I don't think they'll take long. So I think what I'm going to do is I'm going to take the first 30 minutes of class tomorrow. Usually it's about 10 or 15. I might take a little bit extra tomorrow to answer questions. So if that's something that you need or some help you need there, please let me know, okay? Perfect. All right. Well, what I'm going to do is, unless there's a final question, I'll kind of hold off for the next 20 seconds here. Unless there's a final question, I am going to be signing out here. First of all, thanks so much for showing up tonight. I know you could be doing a lot of things tonight, and the fact that you're studying senior year, man, that means a lot, and I really mean that. So great job tonight. Hope you're doing well. And all the other classes, hey, y'all are almost done. Almost done. We've got this. All right, you got it. 21 days. We'll rock and roll. You ready? Out on the make. Oh, that looked good. Hey, have a great night. We'll see y'all tomorrow.